Okay, I'm back, and now let's go over the lab on the formation of the solar system, or it might be entitled planetary formation in your lab. So see if you can find that one. Okay, open up that document. Now, the only measuring device that we used in that lab that you would need to know how to use would be a thermometer. And it's an electronic thermometer, which requires you to press a button on it. So there's a button on the thermometer that turns it on and off. And then it tells you what the temperature of whatever you put the probe into. So that's not much of a measuring device for you to have to master for the exam. But let's look at the concepts. So what did each of these demonstrations illustrate about the formation of the solar system? Okay, so do you remember that we did an experiment where we had the big giant walk, and then we took two balls and we put it into it, and then we let the balls go, and then they were going like this, and then they hit each other. And so what did the two balls do? So how did their direction change? And then what has that got to do with the formation of the solar system? Okay, so if you've done that lab, you know the answer to that question. Okay, then we did another experiment where somebody sat in a chair, and then we gave them two dumbbells, and then initially they had their arms out like this, and then they were rotating, and then they brought in their arms. So what happened to them, and then what has that got to do with the formation of the solar system? Okay, then we did another experiment where there was a ball on the end of a string, and then that string was threaded through a tube, and then the string was attached to a weight at the bottom. And then what you did was you took the tube and you went around your head with it, so that ball was going around and around. And then what did that do to the weight that was underneath it? And then what has that got to do with the formation of the solar system? Okay, then we did another experiment in which we took butter and wax and we put them into test tubes, and then we put them into water, and we heated the water until one of those substances melted, and then we recorded its temperature, and then we did the same thing for the other one. And so we had two temperatures, and then we plotted it on a picture. So there was a picture that had a circle and then another circle around it, and one of those was called the ice line, and then the other one was the rock line. And then one of your substances represented a rocky planet, and then the other substances represented the icy planet. So you should know, based on which one melted first, which one would be more similar to rock and which one would be more similar to ice. So review that part of the lab. Okay, then we did, or you should have done this one at home, where you took a bucket that had water in it, and then you get the water going around and around with your hand, and then you take some tea leaves and you sprinkle them onto the top of the water, and then explain what happened and what's that got to do with the formation of the solar system. Okay, then we did another one where we put some oil, some water, and some BBs into a beaker, and then we shook it. And then one of those substances represented the mantle, and then one represented the core, and then one represented the crust. So remember which one's which. Then we took two metal balls of different sizes, and we put them into a beaker of water, and then we boiled the water, and then we took out the two balls, and then every 5 minutes we felt each of the two balls, and we noticed that there was a temperature change. Okay, you should know which ball cooled off faster, and you should know what has this got to do with planets. So how could that affect the outcome of a planet if it cools off too quickly? Alright, so that, and then there was one mathematical formula, and that was angular momentum. So angular momentum is the letter L, and it's equal to the mass of an object times its speed times its radius. And so we used this formula to explain why a person going around in the chair, when they bring in their arms, they spin faster, because something else is getting smaller. So if something gets small, something else has to get big in order to compensate. So there won't be a math problem where you have to plug numbers into that formula, but you use it in order to explain why the person in the chair speeds up when they bring in their arms. Okay, now let's go to lab on comets and meteorites. So it might be entitled Comets and Asteroids. Okay, so remember we did not do the first part of the lab. So we didn't do anything about making a comet. So there won't be any questions on the lab exam about comets. Okay, because we did not do that part of the experiment. But we did do stuff with the meteorites. And there were two kinds of meteorites, the stony meteorite and then the iron meteorite, the metallic meteorite. And so what I'd like for you to be able to tell me is, could you name two different properties of a stony meteorite, or two different properties of a metallic meteorite that would allow you to tell them apart? So how can you tell the difference between a stony meteorite and a metallic one? And I gave you, I think, about 4 different ways. So could you give me 2 different ways? If I put out on the table either a stony meteorite or an iron meteorite, could you tell me which one's which? Okay, so that is what I want you to know about the lab on comets and meteorites. Alright, so we're going to stop the video here, and then when we come back, we're going to go to another lab.